Okay, so now we're going to try and use our identities that we have over here to do some stuff, to solve different types of problems, okay? So let's look at the problem that I have up on the board. We have if tangent is 5/3, if tangent of theta is equal to 5/3 and is in quadrant 3, we want to find secant of theta, sine of theta, and cotangent of negative theta. Now, here's the truth. We could actually do this using none of the new stuff that we are learning. How? Well, remember we did this way back in the day, okay? If tangent is in quadrant 3, I'm going to draw my angle into quadrant 3, okay? Drop in my reference triangle, and I know that tangent is y over x. So my y is going to be -5 because I'm in quadrant 3. My x is going to be -3, again, quadrant 3. Notice that -5 over -3 gives me my positive 5/3 for tangent. And then I'm going to use the Pythagorean identity to find my hypotenuse, or my r here. So -5 squared plus -3 squared, the square root of that is going to be my r. -5 squared is 25. -3 squared is 9. 25 plus 9 is 34. Let's see, does 34 reduce? 34 is 2 times 17, so no. So my r is the square root of 34. Okay, and then we could say, okay, well, secant, right? What is secant in terms of x, y, and r? Well, secant is r over x. So r over x would be the square root of 34 over -3, okay? You can do that. That is fine. I do not care if you do that. However, just for fun, we're going to go ahead and try and do this using some of our new identities, okay? So let's take a look at our identities. And in particular, we're looking for one that relates secant and tangent together. So one that relates secant and tangent. So scrolling down, scrolling down, scrolling down. Let's see. Secant and tangent. Looks like we're relating secant and tangent together right here. Okay. I'm looking at this and I have an error up here. I'm going to fix it right now. I can't believe I didn't see it earlier. Right? Reciprocal identities. Tangent is equal to 1 over cotangent, which means that cotangent is also equal to 1 over tangent. Man, I must have been in a hurry making that other video. I am sorry. Okay. So anyway, back to the problem at hand. Oh, it's been a long week already. When we're trying to relate secant and tangent together, one thing we can use is the Pythagorean identity that says tangent squared of theta plus 1 equals secant squared of theta. Okay, all right. So let's try and use this identity to solve for secant squared, or solve for secant. So our tangent is 5/3. So I'll have 5/3 squared plus 1 has to equal secant squared. Okay. 5/3 squared is 25/9 plus 1 equals secant squared. Okay. I'm going to turn a light on. I got a weird shadow. Sorry. To combine 25/9 and 1, I need a common denominator, but 1 is the same thing as 9 over 9. So that gives me 25 plus 9, which is 34 over 9, is going to be equal to secant squared, which means if I square root both sides, I'll get my answer for secant. So secant of theta is going to be equal to either positive or negative square root of 34 over 9. Okay. In order to pick which one, we have to realize that when we're in the third quadrant, our secant is going to be negative. So secant is going to be the negative root of this. And so we'll have square root of 34 over square root of 9 is 3, which is the same answer that we got using our reference triangle. Okay. All right. So now let's look at our sine. And again, you could do this straight from your reference triangle here. You can say that sine is y over r, so sine is going to be -5 over square root of 34, which for my math lab we would probably need to rationalize. Okay, but because we're dealing with identities, let's look at our identities and see if we can find one that relates sine and cosine together. Sorry, sine and tangent, which is what we're dealing with, together. Okay. So if we look here at our quotient identities, tangent is the same thing as sine over cosine. Let's see what we can do with that. Okay, so if we know that tangent is the same thing as sine theta over cosine theta, well, what does that mean? We know that our tangent is 5/3, and that's going to be equal to sine theta over cosine theta. We're trying to solve for sine. So if I can figure out what cosine is, we'd be in the money. Now, because we already did this problem here, secant, I claim that we know what cosine is because we can use what? Another identity. The reciprocal identity says, one of the reciprocal identity says that secant is equal to 1 over cosine theta. Okay. Well, look, technically what I have right here is 1 over cosine theta. 5/3 is equal to sine theta times 1 over cosine theta. That's what dividing by cosine means. It's the same thing as multiplying by 1 over cosine. So that means this value here is the one we already found. Square root of 34 over -3. So now I have 5 over 3 equals negative square root of 34 over 3 times sine theta. I kind of screwed up my order, so to just make sure we don't get confused. 5/3 equals sine theta times square root of 34 over -3. Now I just need to solve for sine of theta. I can do that by multiplying both sides by -3 and also dividing by square root of 34. Okay. That leaves me with sine theta over here. And on this side, my 3's will cancel, and I'll end up with -5 over square root of 34. Exactly what we thought we should have by using our reference triangle. Again, I don't really care if you rationalize. My math lab is going to care if you rationalize. Okay? Okay. So now let's look at our last one. Okay. So a couple of things. We're going to want to look at how we can relate tangent and cotangent together, but also notice that we've got this negative in there. Okay? So that probably means at some point we're going to want to consider whether or not cotangent is odd or even. Okay, so let's go ahead and pull our little reference sheet back up. Okay, and let's answer that first question first. The second question first. Is cotangent odd or even? All right, cotangent is odd, which means we have this relationship. Cotangent of negative theta, which is what we have, is going to equal negative cotangent of theta. Okay, and that's explicitly written down here. All right, so the first thing we're going to do is we're going to rewrite cotangent of negative theta as negative cotangent of theta. And now we're going to look at what we can do with cotangent of theta. Do we know how cotangent and tangent are related? Well, let's take a look. Cotangent and tangent are reciprocal identities. So cotangent equals 1 over tangent, or tangent equals 1 over cotangent. Okay. So another way of thinking about that is if we reciprocate tangent, tangent is 5/3, the reciprocal of that would be 3/5. Okay. So cotangent is equal to 3/5, and we'll have that negative sign out in front. Now if we use our reference triangle, remember that cotangent is equal to x over y. Well, in this case, x over y, right, is going to be, I just totally forgot, -3 over -5, which is positive 3/5. But remember, we had needed that negative out in front, so we get the same answer that way. Okay, so again, those are some simple examples of using our identities. And I agree, we totally could have done this without using our identities, but it starts to give us an idea of how we can start to use those identities.